Assalamualaikum and hi, my name is Muhammad SYAHMI bin AZMI. I'm going to introduce my group members, which includes Nur SYAZWANI binti Muhammad IZHAM, FADHILATun NISA binti HAMZAH, and Nur AIMAN DARWISY bin Nur AFANDI. For this assignment, we have chose high performance liquid chromatography as our topic. So what is HPLC? High performance liquid chromatography, or HPLC, is a powerful analytical technique used to separate, identify, and quantify components in a mixture. It is widely used in pharmaceuticals, environmental analysis, food safety, and biochemical research. HPLC operates on the principle of partitioning or adsorption, where compounds in a sample interact differently with a stationary phase, a solid material, and a mobile phase, a liquid solvent, leading to their separation. Now we're going to move on into the steps in HPLC analysis. First is preparation, where we dissolve the sample in a suitable solvent, and next is injection, where we introduce the sample into the injector, and after that, separation, where components separate as they pass through the column at high pressure. And after that is detection. The detector measure the compound as they elute from the column. And finally is analysis. The chromatography shows retention time and peak areas, allowing for identification and quantification. Now for the advantages and limitation of using HPLC. The advantages are it has high resolution and sensitivity, it can analyze complex mixture, and we can do quantitative and qualitative analysis. The limitation of HPLC are it is expensive equipment and maintenance, it requires expertise, and the solvent waste can be environmentally harmful if not handled properly.
The HPLC system is a sophisticated analytical tools comprising key components like a solvent reservoir, pump, injector, column, and detector. It's working together to separate, identify, and quantify the component in the mixture with the precision speed. For the first component is the solvent reservoir. It contains different solvent. The second one is HPLC pump that move the mobile phase, which is the solvent or the solvent mixture through the system. The third one is the degazzer. It attaches the vacuum pump. It functions to remove the dissolved air from the mobile phase to prevent the bubble formation in the system. So it can be performed using the vacuum system. The fourth one is the vacuum pump. It functions to deliver the mobile phase to the system at the high pressure and at the constant flow rate. The fifth one is the solvent mixing valve. It functions to store the standard solution or the sample solution. The sixth one is the sample injector. That function to introduce a sample into the HPLC system. The seventh one is the pre-column, also known as the guard column. It functions to protect the analytical column from the damage and extending its lifespan. The eighth one is the analytical column. Its function to separate the sample component based on their interaction with the stationary phase and the mobile phase. The ninth one is the detector. It measures the amount of analyte acid in the column and convert it into electrical signal. The last one is the recorder. It records and processes the signal from the detector to create a chromatogram for the analysis. Sample preparation is the crucial step in high-performance liquid chromatography (HPLC) to ensure the analytical result quality and reliability. It involves the selecting appropriate solvent, optimizing concentration, filtration, dilution, and extraction. Proper preparation not only enhances the method precision, but it also prolongs the instrument component's lifespan. First of all, we need to understand the analyte. For example, their chemical properties and the concentration range in order to ensure it is a linear range with the detector. Solvent chosen is one of the crucial things because it's mass compatible with the mobile phase of your HPLC system. Common solvent that we usually use is the methanol and the water. After identified with the solvent, the sample need to be prepared by using the appropriate sampling technique. The sample then undergo the filtration to remove the particle that may cause clogging of the column. After that, the sample will undergo dilution, which the sample are diluted to the desired concentration. Extraction of the sample is the isolating the analyte from the sample matrix to remove the particulates, matter, and clarify the sample solution. By using evaporation technique, concentrated the analyte was extracted from the sample matrix to enhance the detector sensitivity. The last one is the last sample preparation is transfer the prepared sample solution into the suitable vial or container for injection into the Hplc system. You must label the vial and store the vial under the appropriate condition.
Now I will talk about technical in Hplc. Hplc normally have normal phase and reverse phase. Normal phase will using non-polar material as the mobile phase, and the stationary phase will be using polar material, while the reverse phase will be vice versa. The other type of Hplc is size exclusion Hplc. Size exclusion Hplc will be using porous bead as the stationary phase. Iron exchange Hplc will be using iron exchange resin as the stationary phase. Now I will talk about technical in Hplc. Hplc normally have normal phase and reverse phase. Normal phase will using non-polar material as the mobile phase, and the stationary phase will be using polar material, while the reverse phase will be vice versa.
Sample of Hplc start with a small amount of sample, which a mix of substance is injected into a tube. The tube that we call column is packed with tiny particles that act as filter, which is a stationary phase. A liquid or mobile phase is pumped through the column under high pressure, carrying the sample along with it. Different components in the sample interact differently with the tiny particle in the column. Different components in sample interact differently with the tiny particle in the column. What is this mean? This means some component of the sample move faster while the other component move slower, which separate them as they travel through the tube. Component with more attraction to the stationary phase travel slower, while the component with less attraction to the stationary phase travel faster. In short, liquid chromatography is like sorting a mixture by how fast the part moves through the special filter and helping the scientists identify and analyze different substances.
In conclusion, Hplc is a powerful analytical tool widely used for separating, identifying, and quantifying complex mixture in fields like pharmaceuticals, food safety, and environmental research. Its precision, sensitivity, and versatility make it invaluable despite its cost and complexity. With ongoing advancement, Hplc continues to be a cornerstone of analytical chemistry, ensuring quality and compliance in various applications.